Hello everyone, and in this video, we're going to be taking a look at a problem that appeared on the 2023 AIME II, specifically problem 9. Without further ado, here it is. Suppose you have two circles that intersect at points P and Q, and you construct the external tangent that is closest to P, and it hits the circles at A and B. You construct a line through P parallel to the tangent, and it intersects the circles at X and Y. We want to find out the area of ABYX, the trapezoid. So how can we get started on this problem? And we're given that xp equals 10, py equals 4, and py equals 5. To get started on this problem, we notice that we have these parallel lines and the tangents, and that would immediately imply that xa equals ap and pb equals py. So these lengths are equal. And motivated by this, we know that AP over BP is equal to XA over BY. We might want to do something with this given the parallel lines and these ratios. So we extend this to hit each other at a point Z, suppose. And now it definitely seems like AZ is equal to AX and ZB equals BY. How can we go about proving this? We already know that triangle APB is similar to triangle XZY, and this is similar to triangle AZB. So these two triangles are similar, but because they share a common side length AB, they are congruent, which means that these lengths are equal. And in fact, Z is a reflection of P across AB. So we can draw ZP and know it's perpendicular to AB. So we have this point W. And we already know that AB is equal to half of XY because there's a homotopy at Z mapping A to X and B to Y. So that means that this is 5 and this is 7, meaning AB is 14. Now that we know the height of now we know the basis of the trapezoid, we need to find out its height, and if we want to find out what the area of it is. In other words, we must find out PW. So how can we get started on proving this? We haven't used the fact that PQ is equal to 5 yet, so we might want to relate it to this external tangent in a way, get it in the picture. This motivates us to extend it to a point M, suppose. And M is the midpoint of AB because MA squared is equal to MB squared, which is equal to MP times MQ. So this length here, so MW is equal to 1. And we want to find out what PW is, so it's equivalent to finding out what PM is. But this is easy by power of a point. We get that AM squared is equal to MP times MQ, as I said earlier. But AM squared is just 6 squared, which is 36. And if MP is some length x, suppose, then it's x times x plus 5. And then if we rearrange it, we get x squared plus 5x minus 36 is equal to 0. And this is an easy quadratic that we can solve. We can factor it as x plus 4 times x plus 9 times x minus 4 is equal to 0. And one of the factors must be 0, so x equals 4, as obviously we cannot have negative lengths. So therefore, MP equals 4, WM equals 1, so let me go ahead and list that. And then MW equals 1. So we can use a Pythagorean theorem to find PW. So PW is equal to the square root of 4 squared minus 1 squared, which is square root 15. And now we know the height of the trapezoid, and we know each of the bases, so we're pretty much done. We can find that the area of the trapezoid is AB plus XY over 2 times PW, which is equal to 12 plus 24 over 2 times square root 15, and we get the final answer, 18 square root 15. this problem is really closely related to Olympiad geometry because we had to use the fact that we have a radical axis in the picture and use some congruent triangles to get some really nice stuff. So, thank you so much for watching this video. I hope you enjoyed.